Hi all, welcome to this video. It's going to be an introductory course where we will be learning the basics of how to create REST APIs using Spring Boot. We won't be using any database as such in this course. Rather, we will be keeping it simple and use some data structures for temporary storage. I would request you to stay with this course till the end, and I'm confident that you will learn a great deal of things. Even though this particular video is an introductory one on the topic of a Spring Boot, I have many videos in pipeline where I would be teaching more advanced and real-world Spring Boot concepts. If you are new to this channel, go ahead and subscribe and also give a thumbs up and comment on the video. This helps immensely with the YouTube algorithm and my motivation to keep on recording quality content. Without any further delay, let's get started with the tutorial. So what we are building today? We are building a to-do application. And here is the agenda for this tutorial. So first we will learn what is the overview of a Spring Boot. Then we will do the project setup for the Spring Boot. And finally, we will be doing the code implementation followed by the demo of the application. So what is a Spring Boot? Spring Boot is an extension of the Spring framework which aims to simplify the bootstrapping and development of new Spring applications. It is designed to get you up and running as quickly as possible with minimal configurations. The key features of Spring Boot are auto configuration, opinion-based defaults, microservices support, and starter dependencies. So auto configuration means that the Spring Boot automatically configures third-party libraries whenever possible. Opinion-based defaults mean that it provides a sensible default for many configuration, reducing the need for manual setup. And microservices support means out-of-the-box support for building microservices with features like service discovery and circuit breakers, etc. Starter dependencies are another great feature of a Spring Boot, which means that using a Spring Initializer, you could include the necessary starter dependencies that will pull in all the necessary libraries. So why should we use Spring Boot? Well, the first thing is that it helps with rapid application development. What it means is that when you use Spring Boot, you will be having less boilerplate code, meaning that you can focus on writing the actual business logic. Second thing is that it's production ready, and what this means is that there are features like health checks, externalized configuration, metrics collection, etc., which make the application production ready with little effort. And then we have the ease of use, which means that it is designed for developers with any level of experience. So what are we going to build? We will be building an application for the to-do management. So essentially, here we will be exposing certain endpoints, certain REST API endpoints, which can be used by this user. And these endpoints are responsible for creating the to-do list, then reading the to-do list, then we can update it and delete it. This is facilitated by this layer called as controller layer. Controller layer in turn talks to something called as service layer, and then service layer is facilitated by this data layer. So don't worry if it's not making much sense as of now. As and when we progress more in this tutorial, it will make perfect sense by then. So let's get started. Now we are on this website called as a Spring Initializer. The URL is start.spring.io. Essentially, this is a platform. This is a tool using which you could start your Spring Boot projects. So using this, you could add all the necessary dependencies, so you don't have to create the project structure, POM XML, and all those details manually. So this is what we will be using for now. So let's see what all do we have here. So first thing is the project. So this defines that what is the build tool that we will be using. And I have selected Maven. You could select either of these three. I'm going with Maven for now. The language is Java, Kotlin, Groovy. So basically you could build Spring Boot projects using these three JVM languages. For now I am choosing Java, and the version that I'm choosing is this one. And now we should be providing certain project meta information, such as what is going to be the group name. So let's call it as com.Shandilya. Then we can call the artifact as to do. And we can call the description as to-do application using Spring Boot. Packaging we will go ahead with ZAR, and Java we can use as 17. Now here what you see is add dependencies. So let's start adding the dependencies one by one. So before we add the dependencies, let's see what all do we have here. So if you could scroll down, you will find that there are lots and lots of dependencies. So remember earlier I told that Spring has this concept of starter dependencies. So these are essentially the starter dependencies. So when you select either of these, any of these rather, then you will be able to add these to your pom.xml file since we have selected Maven. And what Spring Boot will do for you is, what Maven rather will do for you is get all the relevant dependencies. For example, let's say if you want to add Spring Data JPA, which is a component that is responsible for persisting data in SQL stores with Java persistence APIs using Spring Data and Hibernate. So all you have to do is select this and this will be put forward into your pom.xml and all the necessary dependencies, the files and all those things will be available in your class path to be used. So this is a very extensive list that you could go ahead and check out on yourself, but the idea is that the Spring ecosystem has all these dependencies, right? So coming to this project, what we will be needing is, first is we will be using this Lombok. So Lombok is essentially a Java annotation library which will help you in reducing the boilerplate code. So we will see its capabilities and what all it can do in brief when we are writing the code. For now, let's select this. Now let's add another dependency. So another dependency that we will be needing for this tutorial is the Spring Web. So the description is that it helps us into building RESTful endpoints and applications using Spring MVC, and it has a default embedded container that is Apache Tomcat. Of course you could change it, but this is the default one. So to summarize, this dependency is needed if you want to build any REST APIs using the Spring Boot. So let's select this one. And these are the only two dependencies that we will be needing for this particular tutorial. And what we are going to do next is we are going to click on this one, that is generate. And when we say generate, it will download the zip file for us and we could extract it and import in the IDE. So let's do the same. So here I am in IntelliJ IDEA. I'll be using this as the IDE for this tutorial. And now I have opened the extracted project that I have downloaded and I am going to open this one in the IDE. So let's do that. And thus we have imported the project in our IDE. So first thing that we are going to do is let's have a look on the pom.xml file. So it's a typical XML file, pom.xml file that you would expect out of any Maven project. So it will tell you about the details that you selected while you created the project using the Spring Initializer. So this is the group ID, this is the artifact ID, this is the version, name, and so details. The more interesting stuff is here. So you have this dependencies section wherein you can see that there are three dependencies. First is the Spring Boot Starter Web, and second is Lombok, and third is Spring Boot Starter Test. So you can say that, well, we did not select the dependencies for this test. How did it happen? So it so happens that whenever you are going to create any Spring Boot project, this will be added by default. So this is something that Spring Boot is doing for you, adding this dependency for the test as well. And in the build configuration, here you have this plugin for Lombok because the notation processing is something that needs to be enabled and that needs to be available. So Maven is adding this plugin on your behalf. So now let's do a small thing. So as of now, we can see that there is no version that has been specified for Lombok. And at times I have experienced that if you don't provide any version, it will not work as expected. There are certain weird behaviors that Lombok will start showing up. So in order to safeguard us from doing that, let's go ahead and provide a version for the same. So the version that we will be using is this one, which is 1.18.34, and we need to add this here as well. So let's do this. And as soon as we do this, IntelliJ will start showing up this icon, which is to refresh or load the Maven changes. So we will do the same, and now we should be good to go. So let's explore what all have we gotten after importing this project. So in the Java folder, in the Java package, we have this thing where we have this to do application. Now let's take a quick look around what do we have in the to do application that is generated by Spring Boot. So we see that there is a annotation called as a Spring Boot application, and it's placed over this to do application, and it has this main method which is calling spring application.run and to do application.class and the args. So let's understand what exactly are these things. So first is the annotation Spring Boot application. It is a combination of three annotations. The first one is configuration, the second one is enable configuration, auto configuration, and the third one is component scan. So the configuration annotation indicates that the class can be used by the Spring IOC container as a source of bean definition. This is where you can define configuration beans if needed. Enable auto configuration tells Spring Boot to guess how you want to configure the application based on the jar dependencies you have on your class path. Let's take an example that you have H2 database in your class path. Then it might auto configure a data source for you. Auto configuration is a Spring magic which makes your life easy. Then the component scan instructs Spring to scan for other components, configurations, and services in the current package and its subpackages. This means any class marked with component, service, repository, etc. within the same package as to do application and its subpackages will be automatically detected and registered as Spring Beans. So this class to do application is inside this package. So whatever we are going to keep in this package is going to be eligible for bean creation by the Spring Boot. So where exactly do we keep this annotation? So this annotation is typically placed on the main application class, as is the case here, and this serves as the entry point for the Spring Boot application. It is a sign that this class is the root of your application's configuration. And with respect to the package scanning, by default, the component scan will scan for components in the package of the class where a Spring Boot application is declared. So since we have placed this class in this particular package, that is Shandilya to do, whatever we create inside this package will be eligible for package scanning, for component scanning. And the Spring will scan this package and all its subpackages for components, for bean creation, for configuration. So in summary, we can say that this class serves as the bootstrap class for your Spring Boot application. And by annotating it with the Spring Boot application and including the main method with the Spring application.run, you are effectively telling the Spring Boot that hey, here is where you need to start looking for your application configuration. And here is how you can set up your application based on the dependencies you have been provided in the pom.xml. And here is where you can scan for components to add to the Spring context. And finally, this is how to run the application. So this setup effectively allows developers to quickly create and run applications with minimal boilerplate code. And it leverages Spring Boot's auto configuration and component scanning features. So you see, with just a single annotation, Spring Boot is taking care of so many things. So this is the magic of a Spring Boot. And likewise, we will see many more such annotations and understand how exactly it's going to help us into creating applications faster and smoothly. So for now, let's run an application and see the output. So in order to run the application, I'll click on this green button in IntelliJ IDEA and see what is getting printed. So we can see this message. There are certain logs which are getting printed, and it says starting to do application using so and so. Then there is no active profile which has been set. So what are Spring profiles? We'll come to this later. And then Tomcat is the embedded server, and it has been initialized on the port 8080. And Tomcat is being started, And then there is something called a servlet engine which is starting. And finally we can see that Tomcat started on port 8080 and the application has also been started. So the way to access the application is by typing localhost and the port is 8080. So we can see that we are getting this error message. This is because we have not included anything to this particular page. But rest assured, our application is up and running and we can now start with the process of adding certain controllers. Now let's start with creating controller. So we will be creating a package and we will call that as controller, and the controller name would be a class called as to do controller. So let's call this as to do controller. Spring has this annotation called as rest controller. Then we will put something called as request mapping. I'll explain all these things in a moment. So this is how we create controller using Spring Boot with these two annotations. So what exactly these two annotations are doing? So whenever you annotate with REST controller, it tells to the Spring Boot that, hey, I want to create this class. I want to use this class as a controller endpoint. So whatever it takes for a class to be treated as a controller so that it could expose certain endpoints, certain APIs to be accessed, Spring Boot will do it for you. You don't have to worry about anything else. You don't have to worry about servlets. You don't have to worry about what all configurations would be needed. Everything will be done by the Spring Boot itself. So let's see what all do we have in REST controller. So we can see that we have this controller, then we have a response body. So controller is basically a component and response body is something which is responsible for returning the response of the controller endpoint. And request mapping is essentially going to provide the API path. So let's say if I am going to access this particular to-do controller and I'm going to create two APIs, then in that case it will be starting with the server root, that is localhost in our case, followed by APIs, followed by to-dos. And if we choose to expose two endpoints, then that could be followed by / endpoint 1 and endpoint 2. So in order to ensure that this controller thing is working as expected, we will create a simple endpoint. But before we go to that, just as a refresher, so I am assuming that you may be familiar with the different HTTP methods, the different REST endpoints that we can create typically. But just as a refresher, I will tell that we are going to create 4 kinds. So first is like get endpoint, then post endpoint, then update one, and then delete one. So essentially it's going to be a CRUD operation for our application. So let's create the get endpoint to just test if it's working as expected. This controller is working as expected. And the way to do this is by using another annotation called as get mapping. So let's write this, and it also expects us to pass certain parameter, which is essentially the path of this endpoint that you're going to expose. So let's call this as hi, and let's write this thing to return a string, and the name of the function, the name of the method could be say hi, and all it will do is it will return a string called as hey there. Okay. So our expectation is that when we run the application, then we should be able to access this endpoint using get call, and it should be accessible on this particular path, that is API, to-dos and hi, and we should see this message hey there. So let's run our application and see the output. So we are here at this particular location, that is localhost 8080, and we are going to access our API that we have created, that is to-dos and hi. So yes, we can see the message that is hey there. All right. So what it means is that our application is working as expected and we have successfully created one REST endpoint. Now that we have established that our controller and the application is working fine by accessing this endpoint, we will now create different other endpoints. And those endpoints will be to create a to-do, read the to-do, then update the to-do and delete the to-do. But before we do that, let's create the entity. So remember that we wanted to create this application by storing the to-do in in-memory data structure. We won't be using any DB as such. So that is where we will be creating this entity which will be used to store the to-do. So let's do that. And what we will be doing is we will be creating another package, and let's call that as entity, and we will be naming this as to do. So I'll be needing the getters and setters for this class. So one way is to maybe implement the getter and setter, but since we have the dependency for Lombok, let's make use of the Lombok getter and setter. So in case if you are not aware, Lombok is a library, a tool using which we can avoid the boilerplate codes. So we don't need to implement the getter and setter explicitly, rather Lombok does it for us. So what we need to create inside the to-do is, what we need to store inside the to-do is, first is ID. So let's create the ID. That is going to be a final field and it's going to be of type UUID. Let's call this as ID. Then we need a title for the to do, which is going to be of type string, and then we need to tell that a to do is done or not, is it completed or not. So this is of type boolean, and we will create a constructor for to do. This will expect us to pass the title, then the completed value, and first of all we initialize the ID by generating a random UUID. For the title we assign the value that this dot title is title, this dot completed is completed. So that's it for the to-do entity. And now that we have completed the to-do entity, let's create the service. So in this package, let's create another sub package and call this as service. And inside the service, they will create this class and call this as to-do service. So idea is that in this application, this service will interact with the data layer and do all the business processing, whatever is needed to support this particular application. So the way to write a service in Spring Boot is to annotate this with this stereotype annotation called as service. So what is a stereotype annotation? A stereotype annotation is kind of a marker annotation which tells about the role of a class. So essentially, if there is a service, this annotation will tell that its role is to act as a service class. If there is any repository, likewise we have another stereotype annotation which is called as @repository, and the other stereotype annotation which we just now used was this REST controller. So it is nothing but a kind of marker which is going to tell us what exactly is the role of this particular class. We could also have very well probably created this using a component, which is yet another stereotype annotation and a more generic one, right? So that can also be scanned by the Spring IOC container and the bean could be created for that. But the idea is that when you are using a service class, then it's better to annotate with this particular stereotype annotation. And it clearly puts forward the message that this particular class is supposed to be a service class. So moving on, now we have created this service class by annotating with this particular annotation. Let's do the implementation. So inside this class, we will have a list of to do. Let's call this as to do's. Initialize this with an array list, and first of all, we will create this particular method which is going to return all the to do's that we have in our application. So let's call this as find all, then return the to do's. Then we will create this another service method which is going to help us in adding the to do in our application. So it will be called as add to do, no awards for guessing, and it's going to return the to do object itself which is going to be added. So let's call this as add to do, and it will expect us to pass a to do title which is of type string. And what we are going to do is we are going to create a new to do object. We will pass the title. By default it's not completed, so a new to do is being created, so it's not completed, thus the state is false, and we capture this as this to do object. We add this to our to do's list, so to do's dot add to do, and finally we return this to do. So this is completing our another method, another service method, which is add to do. Next is we want to update the to do. So the way to do this is write another method which is again going to return this to do object, and let's call this as update to do. It's going to expect us to pass a UUID. Then let's have the title of the to do, and let's also have the boolean value for the completed field. So what we are going to do here is, first of all, we are going to find the given to do with this UUID. This is the unique identifier of all the to do's, right? So first we find the to do with this UUID, and if it does exist, then we update the values. With what do we update the values? We update the values using this title, this completed, and other details which are not here, but you get the idea, right? So let's write this, and what we are going to do is we are going to stream over the to-dos list and then filter, and we say t dot get id dot to string dot equals and UUID, and then we find the first occurrence. Let's capture this. So this will give us an optional, and let's call this as to do, right? So now we are going to check if this to do had some value or not, because it's an optional, right? So if it had some value, then it means that with this UUID, we have certain value in our to-do list. And what we are going to do next is we are going to capture the value by calling .get on the optional, and then let's call this as updated to do, and the updated to do dot set title with the title that is getting passed in this method signature. And likewise for the updated to do, we call set completed with this completed value. And once done, let's return the updated to do. Otherwise, since we could not find it, we will return null value. This completes the implementation for this particular service method, which is update to do. Now let's implement the final one, which is delete to do. So this is going to return a boolean, as in it was deleted or not once this is called. So let's call this as delete to do. It will expect us to pass the UUID value. Here as well, we should be finding the to do entry with the given UUID, and we could write something similar. But I think this could be factored out. This could be a refactoring, and we could extract it out as a method. So let's do that. So since it's not being used anywhere else, I'll have this as a private method in the same class. Let's call this as private, and it's going to return an optional of to do. Let's call this as find to do by ID. It will expect us to pass the UUID, and we have pasted this from the earlier implementation. Let's refactor it a bit so it's easier to read. So find first, and we need to return this. So now we have refactored this, and now we can make use of this find to do by ID in the places where it's needed. So we could simply replace this with find to do by ID, pass the UUID, and we could just make use of this one in the delete flow as well. So now we have the to do that needs to be deleted by this UUID, and like we did for this particular update case, we'll do the similar thing for the delete case as well. So if to do is present, then we say to do's dot remove, pass the to do dot get, and return true, else return false. So in this flow we were able to delete the given to do, and thus we return true, otherwise we returned false. So this completes the implementation for the service class. So everything that was needed is completed now, and we will try to make use of this service class in our controller now. So let's go back to the controller, which is to do controller, and let's make use of this service class. And how do we make use of the service class now? So remember that in the earlier videos we talked about auto wiring, right? Dependency injection. So we will use the similar concept here. So first thing is that we will provide the dependency for the service class, and since it's a mandatory dependency, we will mark this as final so that it could be initialized in the constructor for sure. And let's call this as to do service. Let's call this as to do service, and since it's final, we need to initialize this in the constructor. So let's do that. So add constructor parameter. So this is one way in which we can do the dependency injection, but since we are using Lombok, we can make use of something called as required args constructor. So what this does is it is going to find out what all fields are final and needs to be initialized as part of constructor, and it will do that for you. So basically all you have to provide is required args constructor. Now with that in place, let's start the implementation for the different endpoints. So the first endpoint is that we want to get all the to-dos. So it's going to return a list of to do. Let's call this as get all to-dos, and we say to do service dot find all, and we need to ensure that it's a get endpoint. So let's call this as get mapping, and going by the REST naming convention, here we have API to do's, and since we are calling get mapping, it means that we are going to fetch all the resources by calling this get endpoint. So we don't add anything extra here. There is no mapping for get. Likewise, Now we need to add an endpoint for creating the to do. Let's call this as public response entity. So response entity is a class in Spring Boot which is going to give you a wrapper around the response, and basically you could decorate it with some other fields as well. So we'll see this in the example. So for now, let's write this as response entity of to do, and then we call this as create to do. It's going to accept a request body, and let's say that it's going to request us to pass the title, which is string title. And this, like we had get mapping, this will be a post mapping. This is to signify that this is a post endpoint. So first thing is that we call the to do service and we say add to do. Let's pass the title, and this is going to return the to do. So what we say is new response entity, and we will pass the to do object. And the second thing that we will pass is something called as HTTP status of created. So basically to the caller, it means that the HTTP status is created and the call went successfully. So that is the benefit of using the response entity. Here you can add such other important details as well, as compared to, let's say, if I just return the list of to do, there was no way to pass around or probably accommodate the HTTP status in this response. So using a response entity is always a good idea. Now let's implement the put mapping for the update to do, and we will be using put mapping here with the UUID placeholder. So the idea is that I should be passing the ID for the to do for which I need to update the to do, right? So like we had get mapping and post mapping, we have this thing called as put mapping, and here we will be passing the placeholder for the UUID. This is also called as a path variable. So / UUID, and this as well is going to return a response entity, and this would be of type to do. Let's call this as update to do, and we have path variable, so we will annotate this with path variable and we will capture this in the UUID. So I am keeping the name as same, so UUID and UUID here. Then we need to pass the request body as well. So basically the request body will contain what exactly I want to update this with. So now what we are going to do is we are going to call to do service dot update to do. We pass the UUID and we pass the to do dot get title, to do dot get or is completed, and this will return the updated to do. So what exactly are we doing here? First we are passing the UUID and we passed the request body for the to do. So let's say if the to do earlier title was something and the completed value was something, now we are going to extract the title and the completed value, and we pass all those values in the service method for the update to do, and this is going to return the updated to do value, right? So now we check if the updated is not null. If it's not null, then we are going to return the response entity, and this will be returning the updated object, and we say that this has been created. So HTTP status is going to be created. Let's call this as new, and finally we return this. And if this is not null, Then we are going to return this, and if this is null, then it means that it did not get updated, and the reason was that we could not find such to do with this particular UUID. If you remember the implementation, that we were checking that if this particular ID UUID is present or not. So coming back to the controller, we return new response entity, and here the value is going to be not found. Finally, let's implement the delete mapping, and this as well is going to expect us to pass the UUID. Here as well we return the response entity, and this can be a void because we are not going to return anything as such. And let's call this as delete to do. The path variable is again the UUID, and using the to do service we say delete, and we pass the UUID. Let's capture the output, which is deleted. This is Boolean type. So if this is true, then it means that we deleted and we have no content to return. So the way to do this is we say return new of response entity, and the HTTP status is going to be no content. Else, if it's false, then it means that we could not find any such entity, any such to do with this particular UUID. So I will say return new response entity, and this will be HTTP status not found. So this completes the implementation for all the controller endpoints that we had. And what we are going to do now is we are going to run the application and then try to execute this via Postman. So let's run the application, and we see that the application has been started on this particular port. So now let's go to Postman, and here I have already created these endpoints so that I don't waste time on setting up these things. So for now I will hit the get to do's endpoint. So this endpoint is this endpoint in particular, that is get mapping, that is HTTP localhost API to do's. For get method I should be getting all the to do's. So I call this, and of course I am getting blank because as of now I have not added anything. Then I will go to add to do, and let's say I am going to pass this to do that I need to buy groceries. So I hit the send, the type is post, and the API path is API to do's, which is exactly what we had here. We had not specified anything other than the base value, that is API to do's. So let's send this, and we can see that we have created this entry with this ID. The completed value is false to begin with. Let's see if it's getting captured in this get to do's response or not. So yes, it's getting captured. So we can see that this to do has been created. Likewise, let's add a few more. So let's say do homework. Let's run this. So this has been added. Then let's say do workout and send. And with get to do's we should be able to see 3 to do's now. So yes, we are seeing 3 to do's. So first is grocery, then homework, then workout. So what we want to do next is we want to update one of the to do's. So let's copy this particular ID. Let's pass this ID over here. So basically update flow is like this, that we need to pass the UUID, and then the request body is going to contain the to do with which we want to update the existing UUID to do, right? So the existing value for this UUID is this one, that is buy groceries, and completed is false. So let's change this thing to the new request body. So basically what exactly is the request body? It's to do, right? So we are having ID, we are having title, we are having completed. So ID is anyway going to be generated here. So we just need to provide the title and the completed field. So in title, let's write purchase grocery, and it has been marked as completed to true. So let's hit it, and we can see that the ID remains the same, of course, and the title is this one, and completed is true. Now when we say get to do's for this one, now it should be like purchase groceries, and this should be completed as true. So yes, now it's purchase grocery and completed is true. So now let's go to the delete request, and delete is again a delete method, and what we can do is we can pass the ID value for the to do that we want to delete. So let's say I want to delete the do homework to do. I can pass the exact ID value here and then hit enter. So when I hit enter, I am seeing no content. That means that this has been successfully deleted. So let's try to get it, and we can see that do homework to do is gone now, and we have just these two. So that would conclude the demo for all the 4 endpoints that we have created, right? And this is the way in which we can create simple REST endpoints using the Spring Boot. And overall structure is like this, that we have a controller, we have an entity, and we have a service. Now if we were to replace this with an actual database, then in that case, instead of using this entity over here, I would have mapped it to some sort of table, maybe some sort of relational or non-relational table, and then the data which is getting persisted in this to do would have been persisted in that particular database table or database collection. So that is the only difference. But having said that, this is the way in which we can create different REST endpoints using the Spring Boot. And since we have used the REST controller, we did not have to specifically tell that what kind of response do we want and what kind of marshalling and unmarshalling do we want. By default, Spring Boot was able to figure out that it needs to produce the JSON response, and then probably it needs to consume the object by marshalling it as a JSON. So essentially what I'm trying to say is that let's consider the get mapping value, that is get all to do's. So basically it's going to give me the list of to do's, but internally what it's going to do is, Spring Boot is going to do is convert this particular list of to do object to a JSON value, that is this one, right? We are getting a JSON output. And likewise, when we are supposed to provide the request body here for the update flow, where we are providing a request to do, then in that case this particular JSON that we are providing in the request body is getting converted, is getting marshaled to this particular to do object. So basically all of these things are being done by the Spring Boot out of the box. We don't need to worry about doing anything else other than writing our business logic. So this will conclude the tutorial for how we can write simple REST applications using Spring Boot, and in the description section you would find the link for the GitHub for this particular tutorial. So that shall be it for this video. Thanks for watching, and please don't forget to subscribe to my channel and like this video, share with your friends and put some comments. Thanks for watching.